Here's our last example with solving a nonlinear system. So I'm going to just jump into it. We're going to go ahead and identify each conic, and right away when I look at this, I got a plus, so I'm dealing with a square here and a square here. Excuse me. So I know we're dealing with either an ellipse or a circle. And when I look at A and C, and these are two different numbers. So this is an ellipse. Now I look at this one, it's a 1 and a 1. Now me putting circles there makes it seem like it's a 0, but coefficients are 1 and 1, and they're both squares, so this guy is a circle. So now as I go through this, I'm thinking, okay, I'm going to rewrite these guys down here at the bottom. So I have 25x squared plus 4y squared is equal to 100. And then I have x squared plus y squared is equal to 25. Okay, I can do a couple different things. I can do elimination or substitution. I might actually choose to do elimination. Reason that I'm going to do that is I see this 4y squared right here, and I see 25. So if I multiply this whole bottom row by -4, the y's would cancel out, and so would the 100. So I'd get 0 there, and that might make the problem very easy to work with. So that's what I'm going to do and see what happens. So let me go ahead and multiply the -4 through. So my next step, I'd have 25x squared plus 4y squared is equal to 100. And then if I distribute this -4 to both terms, I get a -4x squared minus 4y squared is equal to -100. And I'm going to go ahead and just add vertically. So then that means the y's cancel out, the hundreds cancel out. So I'm left with 19x squared is equal to 0. So x squared is equal to 0. Okay, so I got x squared is equal to 0, and I just need to plug that in to solve for y. So I'm going to use this original equation to find y. I'm going to use this one right here. I know x squared is equal to 0, so I just plug in 0, and it makes the problem really easy by seeing that step with the elimination. And so I take the square root, and y is equal to plus or minus 5. So I'm going to put my two coordinates together. I have 0 plus or minus 5. And that is the solution to the system. And if I was to graph these guys, I have a circle of radius 5. Okay, so here is my circle with a radius of 5. And what I did real quick with the ellipse is I set it equal to 1, which gave me this equation. So what I know is that this guy is my vertices, which actually are right here, right on the circle, and then my covertices are going to be 2 and 2, so this is my ellipse. And we see the points of intersection at 0, 5, and 0, -5. So our answer is good. And that's how we solve a system. So sometimes substitution, sometimes elimination. I would kind of take a quick look and see if one's going to be easier than the other, and then go from there.